Hello students, welcome to VidyaVardhini Academy. Myself Dr. Chetan. I am a postdoctoral researcher from Indian Institute of Science, Bengaluru. Today I am here to solve the numericals on electric potential and capacitance. This is the problem. ABCD is the square of side 2 meter. Charges of 5 nanocoulomb, 10 nanocoulomb and minus 5 nanocoulomb are placed at the three corners. Okay. What is the work done in transferring a charge of 5 microcoulomb from point D to the intersection of diagonal? They are asked this question for 5 marks. See here what they have given. They have told the square of sides 2 centimeter. Okay, this is the square. A, B, C, D is the square. They have told the sides of the square are 2 meter. Since the square all the sides are equal, therefore it is all the sides are of 2 meter. Okay, and they told that the charges of 5 nanocoulomb, 10 nanocoulomb and minus 5 nanocoulomb are placed at the corners A, B, C respectively. So therefore I will take A is having a charge of 5 nanocoulomb, B is having a charge of 10 nanocoulomb, C is having a charge of minus 5 nanocoulomb. Okay. And they have told that here in this square the diagonals are going to intersect at point O. Okay, that they have asked that what is the work done in transferring a charge of 5 microcoulomb. 5 microcoulomb, this charge we have to transfer from position D to position O, that is intersection of the diagonals. From here to here we have to transfer this charge. What is the work done in transferring this charge? That we have to find out. That is W is equal to question mark, that we have to find out. Clear? So to find out that one, we have to find out the length of the diagonal, because we know the length of the sides are 2 centimeters. Since it is a square, all sides are equal, that we know. We have to find out the diagonal length. Therefore, to find out the diagonal length, I will consider that is BD. BD is equal to square root of DC square plus CB square. Okay, therefore we know the sides, that is DC is 2 meter, that is 2 square plus CD is also 2 meter, therefore 2 square, that is it is equal to root of 8, isn't it? That is will be equal to 2.828 meter. Okay, now we calculated BD here. Okay, but BD is the sum of DO plus OD, right? BD is equal to, it is DO plus OB. Therefore, we can write this as 2 times the OB, right? To know the length of this one, OB, I am doing this one. Therefore, I will write that is OB is equal to 2.828 divided by 2. That will be equal to the 1.414. What is its unit? It is meter. Okay. Now we calculated this one. Now they have told that the potential we have to calculate the potential at point O, and at the point D we have to calculate the potential. First we will calculate the potential at O. Therefore VO is equal to, we know the formula, that is potential is equal to 1 by 4 pi epsilon. Here 3 corners, the charges are placed at the 3 corners, that is A, B and C. Therefore, I will write this as QA. From this point, from the point O, what is the distance of charge QA is? That is AO is the distance of that one, right? Therefore, I will take this as AO is the distance of a charge Q from the diagonal, that is the intersection of the diagonal, that is QA by AO. The second one is, the second charge is QB, that is QB divided by OB is the distance from the center, and for the third charge QC by OC is the distance from this one. Now we will substitute everything here, that is we know that 1 by 4 pi epsilon will be 9 into 10 raised to 9, and all the charges are in nanocoulomb. Therefore I will take that nanocoulomb, that is 10 raised to minus 9 coulomb. Therefore, I will take this minus 9 outside because it is common in all the factors, and I will take the length. The length between AO, OB and OC is just equal to 1.414 meter. Okay. Therefore, I will take that one also outside. That will be 1.414. Okay, whatever we left over inside is QA, QB and QC. QA is how much it is? Nano, we have taken 10 raised to minus 5 there. Therefore, 5 will be left over plus QB will be 10 nanocoulomb. Therefore, 10 is there. Okay, already we have taken 10 raised to minus 9 outside and we are left with minus 5. Okay, therefore, after calculation of this one, we are going to get V0 as 63.65 volt. This is V0. Okay, we have calculated potential at the point O. Now we will calculate the potential at D. So Vd is equal to, that is the same formula, that is 1 by 4 pi epsilon naught. Okay, now see here in the diagram we have taken that is D is, that is the QA is the charge is 5 nanocoulomb. It is the distance between QA and D is AD is the distance. Okay, this one we have to take. Therefore, Vd is equal to 1 by 4 pi epsilon naught QA divided by distance from the point D is AD is the distance. Okay, plus the second charge is QB is the second charge and the distance from the point D is BD is the distance. Then the last charge, that is QC is the last charge and the distance between them is CD. Okay, now substitute all the values here, that is 1 by 4 pi epsilon naught is 9 into 10 raised to 9. Okay, and QA is how much? QA is 5 into 10 raised to minus 9 coulomb divided by AD is, they have given it is 2 meter. So I will take 2 and QB is 10 into 10 raised to minus 9 coulomb divided by BD is we have calculated BD, right? That is the distance BD is 2.828. QC is minus 5 into 10 raised to minus 9 divided by CD is, it is 2 meter. Okay, here in all this one 10 raised to minus 9 is common. Therefore, I will take it outside, that is 9 into 10 raised to 9 into 10 raised to minus 9. I have taken this as common into, that is whatever left over, that is 5 divided by 2 plus 10 divided by, that is 2.828 minus 5 divided by 2. When we solve this one, we are going to get it is 31.82 volt is the answer. That is, it is the potential at point D. Okay, now we have to calculate if the potential difference between these 2 points. Therefore, the potential difference between the point O and D, that is the difference in the potential dV is equal to V0, that is potential at point O minus potential at point D. Potential at point O is, it is how much it is? It is 63.65 minus the potential at point D is 31.82. Okay, so the change in the difference in the potential will be 31.83 is the difference in the potential. When we got the difference in the potential, what we have to calculate? We have to calculate the work done in transferring that 5 microcoulomb from point D to point O. Therefore, work done W is equal to, we know the formula, it is charge into Q into potential difference. Okay, the value of Q is that whatever they have given in the problem, it is 5 into 10 raised to minus 6 into the potential difference is 31.83. Okay, so the final answer will be 159.15 into 10 raised to minus 6 joule. Okay, this is the work done. That is the work done in bringing a charge of 5 microcoulomb from point D to point O. Okay. Hope you understood the video. Thank you for watching. For more videos, follow VidyaVardhini Academy YouTube channel. Thank you so much.